welcome to another video. Today we will learn about direction cosines. Remember, this part of vector is very important. Then let's go. Direction cosines are the cosines of the angles that a vector makes with the positive x-axis, positive y-axis, and positive z-axis. If a vector A makes angle alpha with the x-axis, angle beta with the y-axis, and angle gamma with the z-axis, then the direction cosines are represented by L, M, and N, where L equals cosine alpha, M equals cosine beta, and N equals cosine gamma. These three values tell us the exact direction of the vector in space. They are called direction cosines because they are obtained by taking the cosine of the direction angles. In the diagram, the blue vector A is shown making the three angles, alpha, beta, and gamma, with the three coordinate axes and the labels L equals cosine alpha, M equals cosine beta, and N equals cosine gamma, indicate the corresponding direction cosine is. If a vector A is written as A equals AI cap plus BJ cap plus CK cap, then the direction cosine along the x-axis is divided by modulus of A. The direction cosine along the y-axis is b divided by modulus of a, and the direction cosine along the z-axis is c divided by modulus of a. Here, modulus of a means the magnitude or length of the vector a. This shows that direction cosines depend only on the direction of the vector and not on its magnitude. The most important relation is L squared plus M squared plus N squared equals 1, which means the square of the first direction cosine plus the square of the second direction cosine plus the square of the third direction. Cosine is always equal to 1 for every vector. Now consider the examples. In example 1, the vector lies completely along the positive x-axis. Therefore, the angle with the x-axis is 0 degrees, while the angles with the y-axis and z-axis are 90 degrees each. Since cosine 0 degrees equals 1 and cosine 90 degrees equals 0, we get L equals 1, M equals 0, and N equals 0. Hence, the direction cosines are 1, 0, 0. In example 2, the vector lies completely along the positive y-axis. Therefore, alpha equals 90 degrees, beta equals 0 degrees, and gamma equals 90 degrees. Using cosine 90 degrees equals 0 and cosine 0 degrees equals 1, we obtain L equals 0, M equals 1, and N equals 0. Hence, the direction cosines are 0, 1, 0. In example 3, the vector lies completely along the positive z-axis. Therefore, alpha equals 90 degrees, beta equals 90 degrees, and gamma equals 0 degrees. This gives L equals 0, M equals 0, and N equals 1. So the direction cosines are 0, 0, 1. These three examples are extremely important because they represent vectors pointing exactly along the coordinate axes. In example 4, the vector makes equal angles with the x-axis, y-axis, and z-axis. Therefore, alpha equals beta equals gamma. Since the direction cosines are equal, L equals M equals N, using the relation L squared plus M squared plus N squared equals 1, we get 3L squared equals 1. So L squared equals 1 divided by 3, and therefore L equals 1 divided by square root of 3. Since L, M, and N are equal, we obtain L equals 1 divided by square root of 3, M equals 1 divided by square root of 3, and N equals 1 divided by square root of 3. The corresponding angle is inverse cosine of 1 divided by square root of 3, which is approximately 54 degrees 44 minutes. Therefore, the direction cosines become 1 divided by square root of 3, 1 divided by square root of 3, 1 divided by square root of 3. The key takeaway from all these examples is that direction cosines tell us how much a vector is aligned with each coordinate axis. A value close to 1 means the vector is strongly aligned with that axis. A value close to 0 means it is almost perpendicular to that axis, and together, the three-direction cosines completely determine the direction of the vector in three-dimensional space. So that was everything about direction cosines. Please check out the entire course of vector in the description. Hit the subscribe button for more fantastic courses like this. Thank you.